Okay, the third force that is acting on a gravity dam is uplift pressure. The first two forces were water pressure and self-weight. Third pressure is uplift pressure. We all know what is uplift pressure. Uplift pressure is caused due to the upward thrust of the seepage water. If this is the cross section of the dam, upstream phase, the water stored in the upstream phase always has the tendency to seep through the pores and fissures of the foundation and come out, and this process is known as seepage. This seeping water will always exert an upward thrust, and that upward thrust is known as uplift pressure. Okay, according to the recommendations, uplift pressure can be calculated as the water pressure itself. That is, if this is the heel and this is the toe, the uplift pressure at heel will be equal to the water pressure at the heel itself. Okay, at the heel, if there is water column of capital H, the water pressure at the heel will be equal to W into H. That we have already discussed in the first case. Okay, if WH is the water pressure at heel, this will be equal to the uplift pressure. So when we draw the uplift pressure is acting in this area. Magnitude of uplift pressure is equal to W and H. In this case, here there is no water on the toe, so pressure at toe will be equal to 0. Okay, so this will be the uplift pressure diagram, and uplift pressure is acting vertically upwards. Okay, second case. If water is present both on the upstream and downstream sides, if the water column height is capital H in the upstream side and on the downstream side if it is H dash, the water pressure at heel will be equal to W into H. Water pressure at toe will be equal to W into H dash, where H dash is the height of the water column in the downstream region and W is the unit weight of the water. So we can draw the uplift pressure diagram like this. W and H, WH will be higher, W and H dash will be smaller. So the uplift pressure will varies like this. Okay, there is another case. Sometimes drainage gallery is provided inside the dam in order to dissipate excess water. Drainage galleries are provided like this. Okay, if there is a drainage gallery will dissipate the water. So uplift pressure will be reduced in such sections. So on the face of the drainage gallery, we can calculate the uplift pressure if water is present on both the upstream and downstream sides. If H is the height of the water column, here H dash is the water column. Okay, at the heel, this is the toe. At the heel, the uplift pressure is W into H itself, and at the toe, uplift pressure is W into H dash. At the face of the drainage gallery, okay, this is the face of the drainage gallery. At the face of the drainage gallery, according to the IS recommendations, uplift pressure will be equal to uplift pressure of the toe, W into H dash, plus 1/3 the difference of uplift pressure on the heel and toe. Okay, that is uplift pressure at the face of the drainage gallery will be equal to sum of the uplift pressure at the toe and 1/3 of difference between uplift pressure at heel and toe. So this is the value. Pressure varies, uplift pressure varies like this. Okay, so this value is important. This value comes only when there is drainage gallery is provided. Okay.